Welcome everyone to the 18th episode of Explained. Maybe you are new to our channel or maybe you've only recently discovered Zenorix. Today's episode is for you because I will tell you everything you need to know about material sensing. I will start by giving you an insight into the foundation of material sensing. Then we will talk about the 4 simple steps that enable material sensing. And then we will move on to the use case possibilities and the benefits. Material sensing is based on the well-established technologies near-infrared spectroscopy and chemometrics. By combining them on a miniaturized chip and implementing it into a handheld device, Zenorix is transforming 2 decades-old lab technologies into a powerful mass-market tool. But what exactly is spectroscopy? So imagine the interaction between an object and incoming light. In spectroscopy, the light created by the spectrometer is first reflected and transmitted by the object and then captured by a detection unit within the same device. This data is transferred to a corresponding software, which is where chemometrics comes into the picture. So what is chemometrics? You can imagine chemometrics as a complex algorithm that reads and interprets inputted data and provides you with easy-to-understand results. Putting it even more simply, it translates spectroscopic data into everyday language. For this to happen, we build chemometric models that are customized to each individual use case. You can learn more about this process in one of our blog posts. I will make sure to link it under the video. Analysis can be enabled in 4 simple steps. The first step is the elimination of the sample. For this to happen, the sample is simply illuminated with a light source. It is important to know that there is visible light as well as light that cannot be seen by the naked eye, for example, near-infrared light. The second step is the reflection and absorption of the incoming light. So the light, once it's shown onto the sample, is then partially absorbed, transmitted, and reflected by the object. In this process, we differentiate between transmission and reflection spectroscopy. In transmission spectroscopy, the light is transmitted through the sample, and then it is detected. In reflection spectroscopy, the light that is reflected by the object is detected. Zenorix XenoLab performs reflection spectroscopy. Step 3 is the detection of transmitted and reflected light. So, the reflected and transmitted light contains information about the sample's material composition. The information gathered is also referred to as the optical fingerprint, unique for each material. To record the optical fingerprint, it needs to be detected and converted into a spectrum for analysis. The final step, step 4, is the identification and quantification of materials. So the recorded fingerprints are interpreted by relevant software algorithms and used to either identify or quantify material compositions. Let's talk about the use case possibilities. Material sensing can be of benefit to a broad range of industries and applications. We have gathered a few examples of what's currently possible when using the handheld XenoLab and the XenoSense OEM module for material sensing. So for example, textile analysis. Material sensing enables mobile textile analysis, which simplifies and enhances incoming goods inspection. Textile processing, textile recycling, and also ensures that textiles are genuine and of high quality along the whole supply chain. Another possibility is yarn testing. Material sensing enables yarn manufacturers to identify and quantify the composition of yarn within seconds. This is important to enable suitable processing and ensure the quality of yarns, as well as of the textiles and fabrics that will be made from it. Another use case possibility is the cannabis analysis. Material sensing poses a reliable and affordable method to analyze the quality of cannabis, determine THC and CBD levels, and ensure consumer safety. Another possibility is brand protection. The application of NIR absorbers on textiles and other materials offers a new way to verify product authenticity. Material sensing enables companies and individuals to detect NIR absorbers and differentiate between originals and counterfeits to protect their brand. Finally, there are robotic vacuum cleaners. Material sensing and OEM modules enhance the functions of robotic vacuum cleaners and make cleaning processes more thorough than ever before. Heavily dirty areas, for example, can be identified and treated more targeted. This is the same for different floor materials. If you would like to get a deeper insight into the possibilities in future applications, take a look at the blog articles I have linked below the video. Now that you have learned all about material sensing, it is time to sum up the benefits that it offers to users. Material sensing saves you a lot of time because it is fast. Measurements take only a few seconds and results are available instantly. Additionally, Sonorix material sensing device is small and mobile. It can be used wherever you are and whenever you need it. Material sensing is also conducted with the handheld device, which makes it very easy. The hardware and software are user-friendly and they require no expertise. It is also cost-effective and Sonorix device can be purchased under a subscription scheme, leaving you in control of your spendings. Finally, the results are reliable and allow you to make informed decisions on the spot. It is time for you to decide whether you need material sensing to enhance and simplify your workflow. If you are still unsure, take a look at the article linked below the video. It outlines the 5 signs that it is time for your company to switch to material sensing. Contact us if you have any questions and subscribe to our channel so that you don't miss out on any future episodes. For now, have a good day and I will see you soon.